Hey guys, one of the most common types of IB math exercises involving binomial expansions is the one that asks you to find a term or a coefficient in a given expansion. Now, they do not ask you to find every possible term, so not doing the full expansion. They do not require you to go through the full expansion. They're only concerned with one specific term. Now, these are two examples, the two examples that we're going to work with. Example number one is find the term in x to the fifth in the expansion of 2x minus 3 over x squared to the eighth. So it would not be practical to expand the whole thing to find that term, which means that you have to carefully find that specific term. That's the purpose of the exercise. And in exercise number two, in a very similar way, you're asked to find the coefficient of the term in x squared in the expansion of x cubed minus 2 over x to the sixth power. So these exercises are quite similar. On the first one, we're finding the term, which also involves x to the power of something, x to the power of 5. And the second one, we're only concerned with the coefficient, but the solution is quite similar. Now, let's get to these. In exercise number one, we need to find the term in x to the fifth in the expansion of 2x minus 3 over x squared to the power of 8. Now, given that we have a binomial to the power of 8, it is not practical to create Pascal's triangle up to the eighth row. It takes too long. And by the way, that's not the idea for this exercise. It's not a sophisticated process. A better idea is to realize or to understand how each term is created. When you're expanding 2x minus 3 over x squared to the power of 8, we will have the coefficients, the binomial coefficients from the eighth row of Pascal's triangle multiplied by a. And what do I mean by a? I'm referencing a general or generic binomial expansion, a plus b to the nth power. We always have n over here. Choose k, and this k is a placeholder that goes from 0 to 8. 2x to the 8 minus 0, or n minus k, times b, which is negative 3 over x squared to the power of k. We can see this pattern emerging in every expansion that we did previously. For example, what is a plus b cubed? This is 3, choose 0, a to the 3 minus 0 times b to the 0, which is just 1, b to the 0 is 1, plus 3, choose 1, which is just 3, a to the 3 minus 1, b to the first power, plus 3, choose 2, which is 3 again, a to the 3 minus 2, b squared, b to the 2, plus, and then we finish with b cubed. This pattern dictates a binomial expansion. So we can write a few terms in the expansion of 2x minus 3 over x squared to the eighth as well. So again, a choose 0 to x to the eighth, negative 3 over x squared to the 0, plus the next one will be a choose 1, 2x to the 8 minus 1 times negative 3 over x squared to the first power plus dot 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 all the way to a choose 8, 2x to the 8 minus 8, negative 3 over x squared to the 8th power. Now, one of these terms will have x to the fifth in it, but what is that term? In this case, we can see more clearly because it's already showing up, but I'll teach you a method in which you can find through an algebraic process which keeps you from expanding the whole thing. Now, let's just see what we have in front of us right now. A choose 0, this is just 1. 2x to the 8th, it's the same as 2 to the 8th, x to the 8th. Don't forget to raise 2 to the power of 8 as well. Therefore, 256 x to the 8th times 1. So this first term right here is 256 x to the 8th plus a choose 1. Anything choose 1 is just that anything. In this case, it's 8. Now we have 2 to the 7th, x to the 7th power times negative 3 to the first over x squared to the first power as well. And right here, we can already see the term in x to the fifth. And that is because this x squared will simplify with this x to the 7th, becoming an x to the 5th. Now, again, this was easier because it was already in front of us, but we can make this exercise a little bit more complicated if we were to find, for example, the term in x to the negative 1, which means something over x, which is somewhere in the middle here. Now, why is this a little bit trickier? Because we cannot see it, and we can either expand the whole thing or use a better algebraic process, which is what we're going to do right now. Just restating something that was mentioned before, the expansion of this will involve terms that look like this: a choose k, 2x to the 8th minus k, times negative 3 over x squared to the power of k. We're going to raise each individual number or variable to the given power. So we're going to have a choose k, which is the binomial coefficient, times 2 to the 8th minus k, times x to the 8th minus k, times negative 3 to the k over x squared to the k. Now, x squared to the k is the same thing as x to the 2k. And when we divide numbers with the same base, we subtract the exponents. Therefore, we can rewrite all this as a choose k, 2 to the 8th minus k, times x to the 8th minus k minus 2k, which means 8 minus 3k, times negative 3 to the k. Now remember, we're trying to find the term in x to the negative 1, so we would like this exponent, which is the exponent of x, to be equal to negative 1. Now, I know this is a sophisticated process, but this is the most accurate method you can use without guessing and checking anything. So again, we want our 8 minus 3k to be equal to negative 1. So we have an equation to solve. 9 equals 3k, so k equals 3. Therefore, we need to choose a term which has k as 3. So we need to go back here and substitute our k by 3. Therefore, we're going to have a choose 3 times 2x to the 8th minus 3, which means 5, negative 3 over x squared cubed. By the way, a choose 3 is 56. We have 32x to the 5th over here, and over here, negative 27 over x to the 6th. When we multiply all of these, we get negative 48,384 x to the negative 1, or negative 48,384 over x. Now remember, this is not matching the previous answer because right now we're finding a different term, one that has x to the negative 1. Alright, so let's jump to the next exercise. Alright, so a very similar exercise. The difference here is that he's asking for the coefficients as opposed to the term. Therefore, we're going to get the answer as something times x to the something, and only the coefficient, which is the number that multiplies x, is going to belong to the answer. We're going to write the answer with only that. Now, despite the fact that this exercise is very similar to the previous one, it serves as an extra practice for that type of exercise, which is quite common. So let's get to it. We know, as it was mentioned in the previous exercise, that any term in this expansion will have the following recipe: 6 choose k, x cubed to the 6 minus k, times negative 2 over x to the k. Now, can I guess and check values for k until I get x squared as a result, something times x squared? Yes, you can, it's fine. However, I'm going to develop this using a more sophisticated process, which was the one mentioned before in the previous exercise. I'm going to raise x cubed to 6 minus k, negative 2 to the power of k, and x to the power of k as well. And we're going to simplify this as much as possible, which means that we'll get 6 choose k. We don't do anything with this, not yet. X to the 3 times 6 minus k. Remember, when you have a power over a power, we multiply the exponents. Then we have negative 2 to the k over x to the k as well. We're going to simplify the powers of x. This one being 18 minus 3k, and this one just being k. We need to subtract these exponents given that we have a division. So we get 6 choose k, x to the 18 minus 3k minus k, which means 18 minus 4k, times negative 2 to the k. Now we want this exponent to be 2. We want the coefficient of the term in x squared. Therefore, if we want 18 minus 4k to be equal to 2, we can build this equation and solve it, finding 4 as an answer, which means that the actual term will be 6 choose 4, x cubed to the 6 minus 4, negative 2 over x to the 4th power. Now 6 choose 4 is 15 times x to the 6th, which is x cubed squared, times negative 2 to the 4th power, which is 16, over x to the 4th. Now these simplify. We get x squared as expected, leaving as our final answer 240x squared. Now, we do need to address the question, which is to find the coefficients. What is the answer for this question? The answer is 240. And that is it. Let's jump to the next one.